Good morning, students. Yesterday we talked about the elastic collision in lab system or lab frame of reference. And we saw that the velocity of the center of mass before collision and after collision in lab system that remains same. All right. Today we will study the elastic collision as far as the center of mass frame is concerned. So I have made three diagrams. Just concentrate on these three diagrams. वो कल वाली ही है पहले. So the first diagram is this. First diagram is this. Elastic collision in center of mass system. Now this is the article. Yesterday I told you this is the diagram number 1. ये वाली. ये diagram है. This is for lab system which we studied yesterday, in which m1 is the mass of the particle. First particle, it is moving with velocity u1, and m2 is the mass of the second particle. And we know that in lab system u2 is 0. It is always at rest, so u2 is 0. And center mass of this and this lies somewhere at the center. Center of mass is this, and let's say v is the velocity of center of mass before collision in lab system. Thereafter, once this mass will collide with this, let us say this m1 goes this way with velocity v1 and m2 goes this way, ये m2 आ गया, with velocity v2. And let us say that angle phi is called angle of scattering in lab system. Alpha is called angle of recoil in lab system. And this is mass m1 now after collision, and this is mass m2. तो दोनों के सेंटर में सेंटर ऑफ मास ये बना दिया हमने. And we said that let us say v dash is the velocity of center of mass in lab system after collision. So we have proved this article yesterday that v is always equal to v dash. The last article we did yesterday, where I have shown that this velocity of the center of mass before collision is always equal to v dash, that is the velocity of the center of mass in after the collision in lab system. So ये diagram हो गया, ये पहले वाला which I explained. Now you see, just come to the second diagram. Second diagram में क्या है? We have taken m1 is the mass which is moving with u1 dash. Now you see we have to differentiate the velocity in center of mass system. So initial velocity before collision of mass m1 is u1 dash. जब dash आएगा तो center of mass frame में बात करेंगे. So this is m1 is moving with u1 dash towards this side, and m2 is the mass of the second particle. It is having velocity u2 dash before collision, and it is moving towards this side. Once they will come, so you see center of mass lies somewhere here. Center of mass is at rest. Center of mass is at rest. So both of them, they will come and they will collide here with u1 dash and u2 dash. This is before collision. This is before collision in lab system. In center of mass system. Then this is second diagram. Now this is diagram number 3 कि what happens after the collision in center of mass system. अब ये particle इधर से आया था, ये particle इधर से आया, ये collide की, एक इधर चला गया, and once this particle goes this way. Let us say they were coming, m1 was coming after collision. This goes this way, m1, and m2 goes this way. So m2 यहाँ से आ रहा था, इधर चला गया, m1 was coming and it is moving this side. So after collision, let us say v1 dash and v2 dash, they are the velocities of the masses m1 and m2 after collision in center of mass system. ये बना दी डायग्राम. और इसमें ये जो एंगल जिससे ये हॉरिजॉन्टल के साथ इधर चला गया और ये भी आ रहा था, ये जो m2 बना रहा है हॉरिजॉन्टल के साथ जो बनाता है, ये भी बना रहा है यहाँ पे. तो दिस एंगल इज कॉल्ड थीटा, व्हिच इज कॉल्ड एंगल ऑफ स्कैटरिंग. Theta is called angle of scattering in center of mass system. And if this is angle theta, तो ये alternate angle है, तो ये angle भी क्या बन जाएगा? Theta. That is which m2 is making with this horizontal line. तो ये इसकी अभी terminology है कि we have explained what is lab system, what is center of mass system, what are their velocities after collision and before collision in center of mass and this system. So this is diagram number 1, this is diagram number 2, and this is diagram number 3. Now we will do the mathematics. Now just understand what happens here in this case. So what we do, what we have said that u1, u2, v1, v2 and capital V, ये सारी की सारी velocities हैं. Mass m1 before collision, mass m2 before collision, mass m1 after collision, mass m2 after before collision, after collision, sorry, mass velocity of m1 and v2 is the velocity of the mass m2 after collision, and v is the velocity of center of mass. ये तो आ गया lab system का, which I have explained. And what we said, let us say u1 dash, u2 dash, v1 dash and v2 dash, ये आ गए हमारे पास. These are the velocities in center of mass system. ये velocity center of mass of frame ले ली हमने और ये ले ली lab frame. Now you see, since both of these frames they are inertial, we said that both of these frames they are inertial. So inertial means what? Inertial दोनों के दोनों frames हैं. Since this both of these frames of reference they are inertial, so therefore Galilean transformations they are valid in these frames of references. Inertial frame कौन सी होती है? Which is at rest or moving with the uniform velocity. So we have considered that these frames of references they are what? They are inertial. तो इसमें अब आप ये लगा दोगे यहाँ पे, since the frames are inertial, so since both frames of references are inertial, so Galilean transformations, which we have studied in our first chapter, so Galilean transformations they must be valid. Transformations are valid in both frames. Both frames. So therefore, you remember the Galilean transformation. What we have said that up from u dash to u or u to u dash, we always write that what is Galilean transformation of velocities. We are writing Galilean transformation of velocities. Therefore, these transformations are u1 dash must be equal to u1 minus v. u1 dash is equal to u1 minus v. एक पता है u dash is equal to u minus v. These are the velocity transformations. Similarly, अब दूसरी भी लिख दीजिए आप यहाँ पे. So what will be u2 dash is equal to u2 minus v. Third क्या हो जाएगी? v1 dash to v. That is v1 dash is equal to v1 minus v, and v2 dash must be equal to v2 minus v. Let us write this is first equation, this is second, this is third, and this is fourth. So we have written the Galilean transformations from one frame of reference to another. If they are valid, if they are inertial, then these relations must hold good. ये आ गया आपके पास. Now we know that in this case, in lab frame, कल भी हमने ये किया था कि what is v is equal to what is the velocity of center of mass. You can check your notes. We had calculated that, and that was equal to m1 u1 over m1 plus m2. ये आपके पास आ गई थी equation number 5. Let us say that this is equation number 5. ये होती है velocity of center of mass. Velocity of center of mass in lab system is given by just before collision. Before collision आपके पास ये आ जाती है. So therefore, what we can write here, therefore ये जो आपके पास ये v की वैल्यू है, आप इसमें equation number 1 और equation number 2 में पुट कर दो. ये जो लिखी हुई है यहाँ पे, we have written this is v, this is v. So you can write substituting. You can write that therefore substituting v in equation number 1 and 2. 1 और 2 में आप यहाँ पे ये substitute कर सकते हो. Equation number 1 will become u1 dash is equal to u1 minus v. This is u1 minus v की वैल्यू ये पुट कर दी, m1 u1 over m1 plus m2, m1 plus m2, or u1 dash is equal to, we can take the LCM, और u1 dash is equal to, इसका LCM ले लिया, ये बन गया m1 u1 plus m2 u1 minus m1 u1 divided by m1 plus m2. We have taken the LCM and ये इसका ये आ गया, m1 u1 will be cancelling with m1 u1, or which is equal to m2 u1 over m1 plus m2. This is u1 dash. This is u1 dash. Let us write this to be equation number. ये 5 था. We can put this as equation number 6. ये तो यहाँ से पुट कर दिया हमने. तो इक्वेशन नंबर 1 आपके पास ये बन गई. यहाँ पे u1 डैश की वैल्यू आपके पास ये आ गई. Now substitute v in equation number 2. In equation number 2. Now you see we are talking about now first in lab system. ये आप लैब सिस्टम की बात कर रहे हो. तो लैब सिस्टम में u2 की वैल्यू क्या होती है? u2 is always the velocity of m2, and since m2 is at rest in lab system, so u2 is equal to 0. यहाँ पे आप ये भी लिख सकते हो, here u2 is taken as 0 because this is lab system. तो ये लैब सिस्टम की वेलोसिटी है, u2 equal to 0. So therefore equation number 2. So therefore ये equation number 2 becomes u2 dash is equal to, ये हो गया 0 माइनस v, और v की वैल्यू आपके पास कहाँ है? ये है. दिस इज माइनस m1 u1 ओवर m1 प्लस m2, और u2 dash is equal to माइनस m1 u1 ओवर m1 प्लस m2. ये आपके पास आ गई. यहाँ पे लेट अस राइट दिस टू बी इक्वेशन नंबर 7. ये आ गई इक्वेशन नंबर 7 और ये इक्वेशन नंबर 6. नाउ व्हाट इक्वेशन नंबर 6 एंड 7 रिप्रेजेंट्स? इक्वेशन नंबर 6 दे रही है u1 डैश और इक्वेशन नंबर 7 दे रही है u2 डैश. एंड व्हाट वाज u1 डैश एंड u2 डैश? यू सी लैब फ्रेम की है, सॉरी सेंटर ऑफ मास की. ये हमने लिया था m1, इट वाज मूविंग विद u1 डैश, m2 it was moving with u2 dash, और center of mass यहाँ पे था, it was at rest. This is before collision. Now you see this is center of mass frame of reference. Here what we have seen that m1 is moving with u1 dash, m2 is moving with u2 dash in opposite direction. तो ये u1 dash और u2 dash क्या होने चाहिए? They must be opposite to each other, and we saw that u1 dash is m2 u1 over m1 plus m2, और ये आ रही है आपके पास, this is u2 dash is coming minus m1 u1 over m1 plus m2, m1 u1 plus m2. So what we write here, you see minus m1 u1, all right, and this is minus, just hold on, u1 dash, हाँ ठीक है, ये m2 u1. तो ये velocity जो है u1 dash and u2 dash, they are opposite to each other. They are opposite to each other. They are coming. Therefore, we can write from this equation number 6 and 7. From equation number 6 and 7, we find that the u1 dash from 6 and 7, we find that u1 dash and u2 dash are opposite to each other. They are opposite to each other. And therefore ये दोनों के दोनों अप्रोच कर रही हैं. So this is opposite to this. So therefore now we write the total momentum of the system before collision. अब देखो elastic collision we are discussing the elastic collision. So we talk about the in elastic collision, we know that momentum and energy, that is always conserved. That is initial momentum is equal to final momentum, and therefore similarly the energy, initial kinetic energy must be equal to the final kinetic energy. अब law of conservation of linear momentum आप लगा दीजिए. So therefore अभी हम बात कर रहे हैं सारी की सारी before collision in center of mass system. So therefore applying the law of conservation of linear momentum of the system, that is momentum before collision, पहले calculate कर लीजिए. Therefore momentum before collision in center of mass frame. Before collision का मतलब क्या हुआ आपके पास कि momentum before collision means m1 u1 dash plus m2 u2 dash. यही हुआ before collision, m1 u1 dash plus m2 u2 dash. Let us calculate how much is that. So this is equal to, you have calculated the value of u1 dash and u2 dash. ये वैल्यू आपके पास u2 dash की है और u1 dash भी आपने कैलकुलेट किया हुआ. So u1 dash we have calculated from equation number 6. I am writing here u1 dash. Just look at equation number 6. This was m2 u1 over m1 m2, sorry m1 plus m2. ये u1 dash है और ये u2 dash है. So let us say momentum before collision कितना आता है? This is equal to m1. Put the value of u1 dash. u1 dash की वैल्यू क्या है? m2 u1 over m1 plus m2 plus m2 u2 dash. m2 और ये u2 dash है. ये आपके पास है माइनस m1 u1 over m1 plus m2. तो ये क्या बन गया? m1 m2 u1 m1 plus m2. This is minus m1 m2 u1 over m1 plus m2. Both of these they will cancel and this is equal to 0. तो आपके पास ये आ गया. Therefore zero momentum before collision आ गया in center of mass. तो center of mass frame of reference में क्या होता है? Once m1 is coming from this side, m2 is coming from this side, and once they collide, then what will be the initial momentum before collision, which is coming out to be 0. So therefore in center of mass frame system, the momentum, linear momentum before collision is 0. Before collision is 0 in center of mass system. अब ये आपने ये निकाल लिया. अब हमने और आगे क्या करना है? Now you see the equation number 7 हमारे पास आ गई थी, and let us write this to be equation number 8. ये जो आ गई, that is m1 u1 dash plus m2 u2 dash is equal to 0. Let us write this to be equation number 8. तो equation number 8 you see, ये इक्वेशन नंबर 8 है, एंड दिस इक्वेशन कैन बी रिटन एज, इसको आप और कैसे लिख सकते हो? दैट इज m2 u2 dash is equal to m2 u2 dash is equal to, इसको ट्रांसपोज उस तरफ कर दीजिए, माइनस m1 u1 dash और u2 dash is equal to माइनस m1 over m2 into u1 dash. So I write here at the top, that is u2 dash is equal to ये minus m1 over m2 into u1 dash. So in magnitude, इसका magnitude लिख लो, magnitude form. तो ये प्लस आ जाएगा magnitude इसका. This is equal to m1 over m2 into u1 dash. And let us write this to the equation number 9. So from here we have calculated what is u2 dash. u2 dash अभी हमने यहाँ से ये निकाल लिया, the value of this. Now we talk after collision. We talk about after collision what happens in center of mass system. तो since देखिए क्या है कि since before collision आपका momentum कितना आया? 0. Before collision momentum is 0 and the collision is elastic. So therefore after collision भी कितना होना चाहिए? It must be equal to 0. So we use this concept of conservation of linear momentum, that the linear momentum before collision and after collision remains the same in elastic collision. So before momentum आपने निकाल लिया था 0. So we write what is the after collision momentum, linear momentum after collision in center of mass frame system. After collision velocities क्या है? v1 dash and v2 dash. So m1 v1 dash plus m2 v2 dash, it must be also equal to 0. It must be equal to 0. So which implies that m2 v2 dash is equal to minus m1 v1 dash, or v2 dash is equal to minus m1 over m2 into v1 dash, or in magnitude v2 dash is equal to m1 over m2 into v1 dash. तो हमने v2 dash भी निकाल लिया, v2 dash निकाल लिया. Equation number 9 थी. Let us write this to be equation number 10. ये आपके पास इक्वेशन नंबर आ गई. So we have used this concept and we have calculated how much is V2 dash, how much is U2 dash, say for example. Now we have to apply the second concept also. Second concept कौन सा था? That in elastic collision the kinetic energy is also conserved. तो आप वो वाला लगा दीजिए. Since collision is elastic, since you see collision is elastic, so kinetic energy before collision must be equal to kinetic energy after collision. अब वो आप इक्वेशन लगा दीजिए. क्या कहती है ये? हाफ m1 u1 dash square plus we are talking about center of mass system. Remember half m2 u2 dash square. This is kinetic energy before collision in center of mass must be equal to after. So half m1 v1 dash square plus half m2 v2 dash square. हाफ m2 into v2 dash square. ये काइनेटिक एनर्जी का आपने लगा दिया. अब आपके पास देखिए क्या क्या चीजें हैं यहाँ पे. और ये हाफ विल बी कैंसिलिंग ऑफ. दिस इज हाफ 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 एंड हाफ. सो m1 u1 dash square m2 u2 dash square m1 v1 dash square plus m2 v2 dash. ये इक्वेशन आ गई. We have calculated. Now we'll be using equation number 9 and 10. 9 में क्या है? u2 dash की वैल्यू निकाली हुई है और 10 से हमने निकाला है v2 dash. तो u1 dash यहाँ पे और v2 dash ये वैल्यू है यहाँ पे. We will substitute these values here. So substituting the value of u1 dash and v2 dash from equation number 9 and 10. Using equation number 9 and 10, above equation becomes, अब इसमें पुट कर दीजिए. दिस इज m1 u1 dash square, m1 और u1 dash square. What is the value of u1 dash square here? Sorry, u2 dash निकाला हो. ये तो है सच m1. sorry we have to put u2 dash. ये वैल्यू पुट करोगे और यहाँ. So this is what m1 as such m1 u1 dash square plus m2 into u2 dash square. u2 dash ये है, इसका स्क्वायर कर दीजिए. So this will give you what? m1 square m2 square u1 dash square. m1 square over m2 square u1 dash square. ये लेफ्ट हैंड साइड हो गई आपके पास. And this is equal to m1 v1 dash square as such m1 v1 dash square plus m2 into v2 dash square. v2 dash square ये वैल्यू है from 10 m1 square m2 square over v1 square into v1 dash square. m1 square m2 square into v1 dash square. ये पुट कर दिया. ठीक है. अब यहां से देखिए क्या क्या कैंसिल होता है. एक m2 से ये पावर कैंसिल हो जाएगी. m2 one power will be cancelling and we are left with this is m1 u1 dash square m1 u1 dash square plus यहां से क्या हुआ. This is you see m1 square upon m2 and u1 dash square. ये बच गया. And this is equal to m1 v1 dash square and plus this is what? m1 square upon m2 v1 dash square. ये हमारे पास बच गया. Now you see what is common in both of these. This is m1 u1 square यहाँ भी है और यहाँ से m1 u1 square dash square यहाँ भी है. So we take m1 u1 dash square. First is 1 plus एक m1 बाहर चला गया, अंदर रह गया. This is m1 upon m2 and this is u1 dash square is outside. Similarly, from here this is m1 v1 dash square. ये चला गया. This is first term is 1 plus 1 m1 left inside, so m1 over m. This will be cancelling with this, and we are left with m1 भी cancel हो जाएगा, and we are left with u1 dash square is equal to v1 dash square, or if we take square root, u1 dash is equal to v1 dash. ये देखो, ये इक्वेशन आ गई इन सेंटर ऑफ मास फ्रेम कि u1 dash is equal to v1 dash. What was u1 dash? u1 dash ये था आपके पास, ये m1, ये था आपके पास m2. It is coming with u2 dash, यहाँ सेंटर ऑफ मास. फिर आफ्टर कोलिजन एक इधर चला गया और ये m1 इधर चला गया with v1 dash and m2 with v2 dash. Now you see what we have seen. u1 dash is equal to v1 dash. u1 dash means the m1 की velocity है before collision. It is coming out to be v1 dash. v1 dash means velocity of this mass m1 after the collision. तो ये आपने बता दिया कि before and after this velocity remains same. जैसे ये आएगा, ये टकराएंगे, जिस velocity से आ रहा था ये u1 dash और v1 dash सेम रहेगा, ये same velocity से इधर को जाएगा. And similarly we can prove. Similarly, we can prove, it can be shown that u2 dash is equal to v2 dash. Now there is no need to prove again this thing, since we have proved that u1 dash is equal to v1 dash. Similarly, we can prove that u2 dash is equal to v2 dash. मतलब u2 dash is equal to v2 dash. तो ये देखिए इसमें क्या हुआ, दोनों velocities क्या रह रही हैं, बराबर रहती हैं. So therefore the magnitude of the velocities of the particles, what we can say, therefore we can say that magnitudes of the velocities of two particles remains the same or remains unaltered in elastic collision in center of mass frame, or in center of mass frame in elastic collision. This is again very important topic, that sometimes they ask these questions and prove that the magnitudes of the velocities before and after collision remains the same. That is, they are unaltered or they remain the same or unaltered in a center of mass frame once the elastic collision is taking place. So that is the article as far as the elastic collision and center of mass of frame is concerned. तो ये आपके पास ये दूसरा आ गया. दिस इज अगेन इंपॉर्टेंट. कल हमने किया था, वी हैड डन द elastic collision as far as the this lab frame is concerned. So both of these things we have covered in both of the frames of references, in lab frame and in the center of mass frame as well. तो ये दोनों आपके पास आ गए. Now I'll give you one assignment which is again very important. ठीक है, तो just do one assignment, and this assignment is, this is a solved again. Now अब आपको पता है कि यहाँ पे एंगल क्या होता है. जैसे ये मैंने बनाए थे, ये लैब फ्रेम ऐसे बना दी थी. ये एंगल हमने क्या बोला था, दिस वाज फाई, दिस वाज अल्फा, ये आपके पास m1, दिस वाज m2, फिर ये m1 इधर गया और m2 इधर गया. तो फाई वाज कॉल्ड एंगल ऑफ स्कैटरिंग, अल्फा इज कॉल्ड एंगल ऑफ रिकॉइल, और ये दोनों कहाँ पे हैं, लैब फ्रेम में. और सेंटर ऑफ मास फ्रेम में क्या होता है, m1 मूविंग विद से u1 डैश, दिस इज m2 मूविंग विद u2 डैश. ये सेंटर ऑफ मास है इसका यहाँ पे, और ये आफ्टर कोलिजन एक इधर चला जाता है पार्टिकल और एक इधर चला जाता है. दिस इज m2, दिस इज m1. तो तो ये जो एंगल आता है, दिस एंगल इज कॉल्ड थीटा. This m1, this angle m1 is making with this horizontal. This is called angle theta is called angle of scattering in center of mass frame. देखो अगर ये एंगल थीटा है तो ये एंगल भी क्या होगा, ये एंगल भी थीटा होगा, ये, because these are alternate angles which m2 is making with this horizontal. This is also called angle of scattering in center of mass frame. तो ये एंगल थीटा है यहाँ पे. अब article which I am giving it to you as an assignment is कि what is the relation between angle of scattering in lab frame and in center of mass frame. ये क्वेश्चन है, अगेन वेरी इंपॉर्टेंट क्वेश्चन, कि अब देखो ये फाई के एंगल ऑफ स्कैटरिंग, ये एंगल ऑफ स्कैटरिंग इन लैब फ्रेम, और थीटा क्या है, थीटा इज एंगल ऑफ स्कैटरिंग इन center of mass frame. And this article will tell you कि what is the relation between angle of scattering in lab frame and in center of mass frame. It means कि you have to find a relation between phi and theta, कि how phi and theta they are related to each other. This is again very important. Kindly do it yourself now. ये सीधा सीधा mathematics है which you can do, and I'll give you ये वाला question. This is a solved article कि what is, ये क्वेश्चन है, what is the relation between angle of scattering, that is angle phi, in lab frame. What is the, ये आ गया, angle of scattering in lab frame and angle of scattering, that is angle theta, in center of mass frame. ये क्वेश्चन देखो, ये अब आपने ये कर लेना है यहाँ पे, और इसमें आपके पास एंगल ऑफ स्कैटरिंग इन लैब एंड सेंटर ऑफ मास फ्रेम, आई विल राइट कि आपके पास ये रिलेशन आता है, और समटाइम्स दे से प्रूव दैट tan phi is equal to sin theta over cos theta, plus m1 over m2. So this is the relation between theta and phi. Theta अब आपको पता है, theta is the angle of scattering in center of mass frame, and phi is the angle of scattering in lab frame. And how they are related? They are related with the help of this formula, that is tan phi equal to sin theta over cos theta plus m1 over m2. This is very important. So kindly do this article, and further you see, you will, इसमें क्या है, यहाँ पे आ रहा है ना, जैसे over m1 plus m2, तो you will discuss the 3 cases. 3 केस आप इसमें डिस्कस कर सकते हो, बिकॉज m1 और m2 है, तो समटाइम्स फर्स्ट केस स्पेशल केस कर लेना, स्पेशल केस फर्स्ट व्हेन m1 is equal to m2, then what will be the relation? Second is when m1 is greater than m2, what will be the relation? And when m1 is less than m2. तो 3 कंडीशंस आप लगा के देख सकते हो, and you can find the relation between this phi and theta. When m1 equal to m2 means both of the particles they are having same mass. दूसरा क्या होगा, when m1 is greater than m2 means m1 जो है वो क्या है, heavy है, उसका मास ज्यादा है in comparison to the second particle. And third is m1 is less than m2 means m1 is lighter particle in comparison to the m2. तो ये 3 केस हैं. उसके बाद these are special cases which you can discuss, and kindly do this as assignment. And rest I'll see, one more probably article is left there in this section or two, so I'll try to send you those also, right? So for today it is enough for you, and thank you very much.